So today we're going to be working on quiz 16A from spring 2018. We're given at the origin when t equals 0, h naught equals 50 milliamps per meter in a vacuum. The electromagnetic wave is in left-hand circular polarization with the wave vector k. And what is the corresponding E field? Alright, so first draw the axis. Call this my x-axis, this my y-axis. And this is because for k we're given the x and y over here, so it'd just be easier if we use x and y axis. So using the right hand rule for axes, we know that our right thumb pointing to the right is our x-axis. Our index finger on the right hand pointing up is our y-axis, and our middle finger pointing towards us is our z-axis. So using this knowledge, we know that positive z is out of the board. And since h is along the z direction, we know h is also out of the board. Alright, so k is 300x minus 400y. So to make it easier, we're just going to use 3x and 4y. So 1, 2, 3, 2, 3, 4. So this is our k. And using our right hand rule, we know that our right thumb points in the direction of k, and our curled fingers point in the direction of h, and E cross h equals k. So having our thumb point toward right thumb point towards k and curl our fingers towards h, when we straighten out our fingers, we see that it points in the first quadrant, and that would be 4 along the x-axis and 3 along the y-axis. This is E1. This is because the angle here is 90 degrees, and this is our alpha, and tangent of alpha is 3/4, and the angle between these two is also 90 degrees, and this is also our alpha, and so tangent of alpha should equal 3/4. So that's why it's pretty much the opposite of k. And next, we can find out E1 is 4x plus 3y, and we have to normalize it, so we divide it by the magnitude, so it's over 5, times, so it's E naught over H naught equals eta naught, and we know it's in a vacuum, so equals eta naught is 377 in a vacuum, and H naught is 50 milliamps, so that is 0.05. So this is our magnitude, which equals 18.85, so times 18.85 cosine omega t, so omega equals ck. You know that 3 times 10 to the 8, and k is the magnitude of k, so it's 500. So that equals 1.5 times 10 to the 11. T, and it's going to be minus 300x plus 400y, because of the equation, either cosine or sine, omega t minus k dot r. Because of this minus sign right here, we know it's going to be the op. We have to multiply the whole thing by a negative, so that's why it's minus 300x plus 400y. And for E2, since it's left-hand circular polarization, we use our left hand. And we know E1 cross E2 equals K. We have E1, which is, so we use our left hand, like I said. So our left fingers are pointing straight out towards E1, and our left thumb is pointing towards K. And when we curl our fingers, we'll get E2. And curling our fingers points into the page. So E2 is into the page, which is in the negative z direction. So E2 equals negative z hat times 18.85, and since it's 90 degrees in phase with E1, sine 1.5 times 10 to 11, which is our mega, times t minus 300x plus 400y. So our total E field is, divide 18.85 by 5 over here, we get 4x hat plus 3z hat times 3.77 cosine 1.5 times 10 to the 11 t minus 300x plus 400y minus z hat 18.85 sine 1.5 times 10 to the 11 t minus 300x plus 400y volts per meter. This is our total E field.